So just to talk a little bit about what you guys have in front of you, you guys have the Raspberry Pi Model B Pluses in front of you. It was kind of a strange timing when this came out. We were able to buy the B Pluses, which we thought were the latest and greatest, and then a week or so later, the Model 2s came out. There's a lot of similarities between the two, but if you take a look at what you guys have in front of you, you've got a very, very small computer. I mean, it's got the footprint of a credit card. It costs $35 individually, and it right now is at least the best-selling computer in England. And the reason for that is because they're giving one of these to every single child in the British system. So I think it's pretty cool. Designed by Eben Upton, one of the things that he recognized as he was teaching in college is that people were arriving with fewer and fewer skills in programming and actual computer use. And so he wanted to design something that would mimic actual computer use, not just application use on machines. So it runs on a Linux-based operating system, very, very small power draw of 1.21 watts. And these pins right here, these general purpose input-output pins, GPIOs, these are things that you can use to take power from and give signals to the Raspberry Pi. So we'll be making use of those a little bit later on. Big improvement over the previous. You've got 4 USB ports, whereas previously on the Model B you only had 2. You have an HDMI output. So one of the things that we're actually really happy here is the monitors that we're working with today would have an HDMI input. Most of the time when we do this, we're working with monitors that either accept only VGA input or a DVI input. And so we bought cables that allow us to use the DVI input on these monitors. So that's what we're set up to do today. It's got a 3.5 millimeter audio jack, micro USB for power. So the same thing that if you're powering an Android phone, that's the same power cord that you can use. And so it's pretty versatile in how you can set these things up, and Ethernet plug-in. So what we'd like you guys to do is connect everything except power. And when you're done, it should look a little bit like this. The only thing is that we won't be plugging in the Ethernet card. We'll be using the wireless cards. So we've already connected the video cables that'll take from the Raspberry Pi to this monitor that's in front of you. Those are already passed out and they're already hooked up. So it should be, use yours as an example, this HDMI right here comes in the back, comes out of the back of your monitor, terminates right here. So that's the video card, that's the video connection you're using. I have an HDMI monitor, but honestly, after I set it up once and get its IP address, I tend not to use the monitor very much at all anymore. Your login for first-time use and for all uses, unless you change anything, is Pi. Your password is Raspberry. And so when it asks you, and it's on the slides that I handed out to you. Going past the getting online step is to play around with getting some folders there. So we found the terminal. If you can't, open up the terminal. My guess is most of you guys are comfortable working in a terminal environment. Yes? OK. So we don't have to spend too much time on this, but some of the terminal comments, some of the terminal commands that are really helpful for us. If you're on the top right corner, you should see like a little black box, like it's a monitor sort of thing. If you double click and open that, you have the terminal open. And when you're booting, you're also in the terminal. Depending on what you want to do with the Raspberry Pi, you never actually have to go to the guided user interface. So you can do everything you need to do from the terminal. Some things that are good for you to do and to know is to know where you are. So what is your present working directory? PWD, hit that and enter. If you want to make a new directory, mkdir space and whatever the name of that directory is to be, mkdir like camera or mkdir name. And then to change directory, to change your location into that directory, cd into that. cd ... will move you back one level in your browsing history. And cd tilde is what you'll do to get home. What I would like us to do is the next thing we're going to do is we're going to spend a little bit of time working with the cameras and having fun with those. So what you'll want to do is you want to make a directory called camera. So in your home directory, if you were to do cd or cd tilde, come back to your home directory, your present working directory, and then make dir camera. That is, you're going to make a new directory called camera. So the reason we're going to do this is because we are going to pass out the cameras now, and we are going to start taking pictures. Okay, so there is a helpful video for plugging in the camera. Raspberry Pi put one out, and probably the easiest thing for us to do is to pass out the cameras first. The thing I want you to be aware of is, these are live boards. So when we're going to be plugging things into live boards, you should probably power them off. That is, you'll want to take out the power cord from your Raspberry Pi when we plug in a camera. This is the Pi No-IR camera. It's a 5 megapixel camera, and what we're going to do is we're going to plug it in. So, all right, so behind the Ethernet port, there's a camera gate. You lift up on that gate. This blue portion faces this. Plug it in there. Make sure it's seated. You can feel the bottom with your 2 thumbs. Push down on the gate. Give it a little tug to make sure that it's secure and your camera's connected. With the Raspberry Pi plugged in again, so what we need to do now is we need to tell the computer that the camera is plugged in, we need it enabled. So the way that we do that is you need to go to a configuration file. So in that terminal, we're going to be using the terminal a lot today, so get kind of comfortable with it. Sudo raspi-config, raspi-config. Sudo means super user do. And the way that these are set up, it means that you have root access to this, so that you have the ability to make all the changes as if you're the administrator for this computer. Other computers may not be set up this way. This is the way you are currently set up. So sudo raspi-config, one of the, that'll take you back to that blue screen with the gray box. Okay? So if you are not there, you'll want to get there. Go down about 4 options, and there should be an enable camera. Select it. It's going to ask you if you want to enable the camera. Just keyboard over to where it says enable. Hit enter. Go down to finish, and you're going to want to reboot. So one thing about this, you may use the camera for a lot of things. You only need to do this once. That is, you tell this computer that the camera is connected only once. You only have to do that one time. A few things about the camera. It's a 5 megapixel camera. It's got different video modes. One of the interesting things is that you can do up to 90 frames a second. And so if you're interested in filming things in slow motion, I'll show you guys a slow motion explosion that I did for my chemistry class. It's really, really cool, and explosions look great that way. So when you do that, you need to set a certain resolution. So 640 by 480 is what's required for that. Everything else makes a lot of sense to intense camera users, but it's a very powerful camera. I've been able to do a lot with it. So the command, you guys have it in front of you in the handout that I've given you, but the command is this. From the terminal line, you're going to write the word raspi still. There'll be a space, -o, meaning output. There's an output from this execution. Then another space. The name of the file, which I'm just right now generically calling picture.jpg. So you'll make a JPEG file. Once you do that, on your screen, you should probably see like a full image of whatever that camera is pointed at. It could be you, it could be the person behind you, it might be the ceiling. Okay, but you'll start to see that that picture is there. When the red light is on, that means it's getting ready to take the picture. It'll freeze for a second. That means the picture has been taken, and it is done being a camera at that point. Every time that you've taken a picture and you've called it, let's say, picture.jpg, and you take another picture, your last picture.jpg got overwritten. So if you're interested in taking a series of pictures, obviously we'd have to do something where we change the name every time. And there are ways that we can do that either with a Python program, or there are ways that we can do that just through a bash script. There are other things you might have noticed where the way you're holding the camera, you appear upside down, or whatever it is you're interested in looking at is upside down. So there are arguments that you can add so that you can change things about the way the picture is taken. So raspi still is still the name of whatever it is the program you're taking a picture of. -vf means vertical flip. That is, it'll flip it vertically. And -hf means it'll flip it horizontally as well, so that you don't actually have to change the orientation of the camera. Those things will be changed for you because you told the camera to do that to the image. and then end with -o, whatever you're calling the file.jpg. One thing you could do, if you take the folder that we just created for this, the camera folder, and you decide to say, OK, I want this picture to not just go to my home directory, I want it to go into the folder, how would you change that line? Yeah, so you can do it just from the root directory if you want, /home pi camera. OK, that's one way you can go about doing it. See if you can make it so that the picture that you take lands in that folder. OK, try some of these. There's another one that we can do. There are some effects. So -ifx will add effects to these things. So you can make it so that your picture looks like a negative. You can solarize it. You can sketch yourself, oil paint yourself. So those are some neat things. Play around with those and see what you see. If you think about this for a second, and it's a thing that we want to make sure that we're always in a capacity to do. When you're taking these pictures, there are easier ways to take pictures, right? So then you start to think to yourself, well, what do I want to take pictures? Could I use this to take pictures of something that shows something dramatic? And there's a bash script, and there's a lot of great examples that you can use for taking pictures sequentially over long periods of time. And that would be like time-lapse photography. And for time-lapse photography, you want to take pictures of things that change dramatically, but slowly. And that would be things like the sunset, or clouds passing by, or just the movement of people in a crowded space over a long period of time. So what I'd like to do is on this next one here, we can show you how to take those pictures. One of the things you probably notice is that every time you take a picture and you want to keep that picture and not overwrite it, you have to change the file name. In the terminal, what we can do is we can give it a command so that it'll do that. So if you take a look at what's up here, Raspberry still -o home pi camera picture %03. There should be a D after that, so this something did not get saved. So the program is called Raspberry still. The output destination name of the file -o home pi camera / and then the name of the file. So I'm just calling them picture. OK, so when the letter D is there, it means that after it's going to append that file name with a 3-digit number starting with 0. So it'll be 000, 001, 002, 003, and so on, .jpg. The next thing you'll do is -tl, and that means a time lapse. That is how much time between pictures. And it's measured in milliseconds. OK, so the way I've gotten I put the number 10,000 right here. That means 10,000 milliseconds. It means I want it to take a picture every 10 seconds. For the total length of time, -t, and the parameter there is 120,000 milliseconds, which is 2 minutes. So total time in milliseconds for all pictures. If you write in something like that, if you write this command, what will pop up on your screen is you'll see a preview for this entire time. And you will be able to, every 10 seconds, that preview will freeze and take a picture. And then if you go to the file folder that you put all this in, and if you're in the terminal and you hit ls, you list contents, you'll see 10 photos, 10 files there. If you're doing this from the GUI and you've opened the file manager, you will see, again, you'll see 10 photos sitting right there. The great thing about them is because the way they're ordered, the first one's first and the last one's last. And if you're making a time-lapse movie, that's very important. The first one first and the last one last. OK? Go ahead and try something like that. You can shorten this. If you don't want to wait 10 seconds for each one, you can take off a 0, and now it's 1 second. You can do it for 2 minutes. You can do it for 15 seconds. But try something like that. A lot of you guys have other computers out here, and that's great. So if you do a Google search for Raspberry Pi push-button camera, push-button stop-motion animation, the resources that the Raspberry Pi Learning Systems has are wonderful. So if you just click here on Get Started, more or less everything we've done is here. But what they do differently from us is they move quickly to a Python program, which we can do. We can go through these steps. The problem is, without being online, we lose the ability to copy and paste. So you have to type in, and syntax might be the next frustration. So we can do that or not do that. But what they do is they run a program. What we did is that we use this breadboard and use the input-output buttons to drive it. So every time this button got pushed, the camera took a picture. And if the monitor was set up, they could see that what the picture was taking a picture of. So boom, picture, 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 and they were able to do it. So it took about an hour and a half for them to go from unboxing the first time to having this thing set up to work. And then once that all got set up, they were able to do it. And then the stop motion animation, this is the code that they ended up using. It's all available here for copy and paste. And this is the part that we did not do. So there is a rendering it so that you can watch it as a video like we just did there on YouTube. It's a little bit of a trick. So the thing that you would have to do is to get these photos off. Okay? And there's a couple of ways you can do it. The way I'd recommend doing it is using something called, let's go. I'll come back to that in a second. Is using something called this. So it's WinSCP. It's basically a file transfer protocol system. And so if this and your computer are on the same network, you can just get its IP address and then access it and then pull every file off, so that every file is now on a computer that you're more used to working with. Once all those things are taken, there's a few programs you can use. At the time, I was using Cineform, which is the GoPro one. Also, Windows Movie Maker works out really, really well. And if you're working with Apple products, iMovie works really, really well for putting these things together. So you can go through and you can get all those pictures taken. And then you have the movie made, and then your students can go through the process of like, oh, let's add sound, let's add titles, let's do some other fun things. And they can get really, really creative. Also, the things you decide you want to take pictures of can get really clever. So I've got these, as I mentioned before, I'm a chemistry teacher, so I've got these hydrospheres. What they do is they absorb water really, really well, and they get big. So I get these big spherical, very clear balls. And what they do is they allow me to start taking, I can actually use those as a lens. So I'll put those in front of the Raspberry Pi and then start taking pictures of things behind it where it gets spherically, altered and it gets inverted. That's kind of cool. And then I can dye it with a fluorescent molecule. And so I've done that. And then if I illuminate that with UV light, which I'm working on next, I can make the inside of that appear dyed, which always looks really cool. I'm super excited about that. Other ways that you can do it if you don't want to use the WinSCP, through a Python program, you can actually make it so that these will go right to your Dropbox as they're taken. And if they're online, that's something that's relatively straightforward that you can do. There are some instructions that are set up through Raspberry Pi TV. And after the break, we can show what some of those look like. But basically, it allows developer access to your Dropbox account. And it's very satisfying. So if you can imagine, I'm doing, let's say, I've got this Raspberry Pi set up outside. I don't have a really good way of connecting a monitor to it, so I have no real way of making sure that it's still taking pictures when I think it should be taking pictures. So if it's uploading to a Dropbox account every time it takes a picture, that's a very satisfying way of knowing that, yeah, this is working, and I can see what's going on if anything needs adjusting. Also, the Python programs, they don't require much programming experience, and they're all laid out there for you. So it's the sort of thing where you can grab the code, put it in there, and then make adjustments to make it do what you're looking for it to do. You can tell a computer to take pictures the way that you want them to be taken. I want to show you a video one as well. So raspivid is what you would do to make a video. So it's the same command. You don't need the capital R. That just happened with PowerPoint. This right here, FPS, frames per second. So if you're going to take something at 90 frames per second, it can only be so big as far as the camera is concerned. So again, this is the length of the video, and this is the output location, and it's going to be a .h.264 file. So when you go through and do that, it ends up making a video. So this is using, it's called a wish bottle. And this is with the no IR camera, the one that you guys are currently using, meaning it doesn't have an IR filter on it. So that's a bottle that's got some alcohol in it, vapors, and I dump out the extra liquid, and then I light the vapors, and you get this giant whooshing sound. And if you're watching it live, it takes about a second. It was done with no IR filter, and I wondered, well, what's the difference between no IR filter and one with an IR filter? So I filmed it with two cameras at once, two Pis, two cameras, and split the screen using one just a visible camera and one an IR, the no IR camera. So this is the same event. And you can see you're picking up different stuff. So you are definitely picking up some of the heat signatures. Remember, infrared radiation is like, heat signature, that kind of thing. So you're picking some of that up. It's pretty cool. There are a couple things that you can think about with the picture taking. One is obviously, and as educators, like, what do you want to do with it? What are the things you want to watch? The technology works, yes, and it's fantastic, but what can I actually apply it towards? And so if you look around and see what sort of things people are actually interested in, connections with some of the other departments in your own schools is going to be like prime resources for you. So, obviously I pull heavily from the sciences, so watching seedlings grow from seeds into plants, very exciting. A lot of really cool things happen in the first several days of growth. Watching crystals go from solution, so you have like a solution, a highly concentrated solution that has some like copper sulfate in it, and then you let the water evaporate, you'll start to see crystals form. It's a really beautiful thing. Bacterial growth, it was recommended to me that we get an agar plate and then have someone kiss it so that you get bacteria growing in the shape of lips, which I think would be, again, if it works, really cool. I'm not going to volunteer for that one. And then decay. So the first thing I tried was to try and get rotting fruit. One of the things I do in my spare time is I judge a lot of science fairs. And with the science fairs, some cool things happen, but one of the more common projects is students will try to show, like, under what circumstances do bananas rot the fastest. Okay, and usually one bruised banana seems to make the others bruise a little bit faster, so I thought, okay, if I put a few together, one is bruised, the other is not, I should see the others start to bruise over time. And as I was watching that, some things fell out of my control. So I only have like one room in the house where I really have control over the lights, and that's down in the basement. It's also the same room that my wife works in, so she decided she didn't like the smell of rotting fruit anymore, and turned the lights off in that office as she leaves. So as she did, lights went off, and like it changed the pictures I was taking. And so when I did it all as a video, all of a sudden there's a dramatic change, and it's the lighting, and I can't see the things anymore. So when you set these things up, you really got to think about what sort of things are in your control, and how much space you're going to need for the pictures in terms of memory. Are you taking pictures every 10 seconds, every minute? What is most appropriate for what you're trying to do? And those make for really good, really visual projects. As I've been fooling around with this, it seems to me that the camera is probably like the single best gateway drug for getting into things that you can have a computer do. And if there's any aha that I took away with like things from the Raspberry Pi, it's that I'm not using it like I would use like my normal laptop or the home computer. It's something I'm sending instructions to and asking it to do stuff for me while I'm not around. And that's the biggest change for that computer than for me. Yeah. Live stream you should be able to do. What'll probably happen is when we download Apache and set it up as a local web server, it's a local web server. So when it's out there to anyone whose computer is on the same network as that one. If it's going to be on the other side of a firewall, so it's open to like the World Wide Web, that'll be a little bit different. Okay, so yeah, you can still do that. It's just a different process, and then your IT staff will be very interested in its security options. For local stuff, if you're doing it in your home or in a classroom setting where you do have access to the ability to network various computers, they'll be able to find it all instantly. Okay, as long as they're on the same network. So yeah, that's definitely something you can do. So I showed you the video, making videos. The reason we're not going to make videos is because the Pi does not necessarily have its own video player that you can use very easily to see the video that you just made. The command is still the same. The R right here should not be capitalized, but the rest of it's the same. This is the program, the size, frames per second. If I take this out, it's just standard video, length of the video, and where it's going to end up. The one thing that I needed to do in order to show this up is I searched for H.264 to MP4 converters. There's lots available online. You load up the file, you get an email when it's ready, and then you can download your file. So whatever your file is called, you get it back as an MP4, and then that you can take into Movie Maker or whatever else. If I'm using Windows, I'm using Movie Maker. If I'm using an Apple, I'm using iMovie. And then you can play with it. Then you can add your sound. You can add your titles. You can add all the things you need to add so you have a very high quality movie. And then this is the sort of thing that you can put out to YouTube if you're interested in that, or whatever you're interested in. OK, so what we're going to do is we make a local web server. So we're at if you have the handouts in front of you, we're at the page 2 portion. Typically, before you start any project, you'd want to update and upgrade your computer. With the spotty nature of us being online, and with the length of time this could take, I don't recommend doing it right now. Generally speaking, before you start any project, you would want to do this. We don't need to do it right now. I think we're probably in pretty good shape. But if you were to type these two commands, sudo apt-get update and sudo apt-get upgrade, after you do update, what it does is it looks at your computer and looks for things that need updates. After you do upgrade, it goes out online, gets all the things that need updates, bring them back to your computer, and updates your computer. So you should do that before you start any project. It's just something we would take a lot of time, and we don't need to dedicate that time to it right now. So what you want to do now is sudo apt-get install apache2-y. So we're going to install Apache on your computers. And the sudo does not need to be capitalized. Just about everybody has gotten their IP addresses figured out and has downloaded Apache. These are two good things. If you pointed your browser to the address that you have on file, the internet address there, you should see something saying it works. So that is like the index.html file that is sort of default on your machine. What you can do now is you can make changes to that file. So Nano is a really good text editor that comes on the Raspberry Pi. So if you type in sudo, again, super user do as I say, space nano is the name of the program. So sudo nano space, I'm sorry, I forgot something. You have to go into this folder. So cd space /var/www. You need to go to that folder. var/www. Okay. Type in sudo space nano space index.html. It's going to open up that file, and what you should see is a simple HTML file that shows it works. If you make a change in that and save it, make that change, save it, and then go back to your browser and refresh it, the change that you made will be reflected in the browser. At this point, we're sort of ready to go on to our third project, which is building a temperature sensor. I'm going to walk you through the steps of it really quickly. We're going to use a breadboard, build out a temperature sensor. We're going to copy a Python program and run our ability to get temperatures through a Python program. So we're going to build a little circuit that looks like this. We've got the wires, we've got the resistors. You can ignore this piece right here. It's called a Pi cobbler. We'll go over like what these things end up meaning and doing. So we're going to prototype this out. We have to make one configuration to the config.txt file. I don't know why. One of the things that happens with Raspberry Pi is that they'll ship things when the hardware is ready, but not necessarily when the software is ready. So there's a quick fix that we have to do, so we'll do that. And it's only one line of something, so it's really easy. And then we will activate it and start getting temperatures. So we'll get temperatures. It'll look really cool. Then we're going to download something, and I'm going to make this optional, but it's really quite powerful. We're going to download something called GSpread. It's a library for Python. And what that will allow you to do is take the temperatures that are being read at your temperature sensor and report them directly to a Google spreadsheet that you created. The reason we make that optional is because Google's enhanced security will think that if a program like this is trying to access your Google account, that you're being hacked. And so you have to change your security settings, and you may or may not be comfortable doing that. So we can walk through that step, and what will happen is you'll hit a button on your computer here, and a temperature will appear on your Google spreadsheet if you're watching that on another computer or your phone or something. It's a real big wow moment. So if you take a look at what's in front of you, you see two columns, like a plus and a minus. Okay? Everything down that column is an electrical contact. So if you look at the one with the blue right next to it, if you were to plug something in, like one of your wires with the male lead into it, into that would be an electrical contact with everything below it. Everything in that column would be an electrical contact. Okay? If you were to plug something into the red one, it would be an electrical contact with everything below it in that column. Okay? The plus and the minus right there, those two columns are not in electrical contact with each other. They're separate. All right? See this group of 5 that's right next to them? They might have letters A, B, C, D, E, or F, G, H, F, G, H, I, J. Okay? Those 5 going across in a row, those are an electrical contact. So if I plug anything into that first little spot, the next 4 things, if I plug in anything there, would be in electrical contact with what I just plugged in. So going across, those things are in electrical contact. Going down, they are not in electrical contact with each other. So if you need something to go, touch one thing and have the other end touch something else, they need to be in different rows. Across this breaker, okay, that sort of is a break in the line, so that these 5 here are in electrical contact with each other, but not with the things below it and not with the things on the other side. And then it just repeats it on the other side. This blue line all the way down, those are in electrical contact. The red line all the way down, those are in electrical contact. Okay, so the pins that we're going to use, the top left one right here, this pin, you want to plug something into that. The female end gets plugged in there. The next thing I'm going to have you do is if you hold on to your temperature sensor such that you've got, you can see the writing on there. So, and there is writing on there, I assure you. It says Dallas. Okay? You hold it so that the curved edge is away from you. The top one right there. So what you do is you flip it around so that the curved edge is facing in. One of those prongs goes into each one of these, like so. And goes like that. Next, we need a resistor between the 3.3 volts in and the next one over. So you take your one end of your resistor, put it in that line. The other end of the resistor goes in the one directly beneath it. What you do now is you take the second wire and count 2 away from that. So 1, 2 empty pins, and then put this one down. It's the 4th. It's going directly above something that says GPIO. The other end, the pointy end of that, will go right next to the other wire that you plugged into the breadboard. The last little bit, after your second wire is plugged in, is you take the female end for your last wire. This will be the ground wire. It goes on the right-hand side of where all these come down. The right-hand side. 1, 2, 3. That's going to be ground. And you plug that into right below the second one you plugged in. So you should have 3 wires sort of plugged in right next to each other. It'd be in the 3rd pin down. So it's on the right-hand side, 3rd pin down, that's ground. And then it's the 3rd pin down on your breadboard. Once you're confident that you've got this connected, if it doesn't work, we'll know pretty quickly. It's either not going to show up in the devices folder, or we'll get a nonsense temperature. So we'll know pretty quickly if it's not set up. And there's no damage to be done right now. So what you want to do is turn your Raspberry Pi back on. For the time being, you don't need to go to the GUI. You can leave it in the command line. And you're going to want to do this. This is, I don't know why we have to do this, but these did not function until we did this, and I trolled a bunch of forums to find out why. And again, the only thing I can really come to the conclusion of is hardware gets shipped before software is ready. So what they needed to do is make sure that all the GPIO pins work. So once you're at your command line in your terminal, you want to execute this. You want to open up this config file. So sudo nano space /boot /config.txt. You want to open that up. What you want to do now is we're going to write a couple commands. Now it's in the handout you guys have. So everything I'm showing up here, you guys also have. So we're going to activate the pins for reading. So in the command line, sudo space modprobe is one word, space w1-gpio. You hit enter. It acts as if nothing happened. Then you do the next line, sudo modprobe w1 therm. So the next thing we want to do, what we're going to do is we're going to go to the folder where your device is located. Okay? So the way you do that, we change directories. So it'll be cd space, and we're going to go to this absolute file. So sysbus w1 devices. When you're there, after you do that, type ls. It's not listed up here. I can change this so that it does say that. But what I'm looking for is a long number that starts with 28. If you've done this, or if you did it right, or if everything worked right, I'm sure you did it right. If everything worked right, you're going to see something that spits out some numbers and letters. And at the bottom, you're going to see something that says T equals some number, some 5-digit number. It starts with a 2. That's the temperature in Celsius times 1,000. Okay, so the temperature in this room is not 21,937. The temperature in this room is 21.937 degrees Celsius. If you put your finger and hold it on that transistor for a little bit, and then you hit up arrow and do it again, you'll notice you get a higher temperature. In this step, what you want to do is make sure you have a Google account. In the computer, you're going to type in this process, git clone this web address, and then it's going to go into a folder called gspread. So what you're trying to do is you're trying to download this Python library so that Python can use it. So you go through the rest of this CD into that folder, run the setup and install, and then reboot so that your Python library, your Python program, when you use it again, will be able to accept gspread. The next step, I'll move to the next slide and then I'll come back, is you're going to want to create a Google spreadsheet, and you're going to enter, you can make sure you know its name. So if you're going to call it something like temperature or today's date or whatever, you just need to know the name of it. And it's going to be case sensitive. You'll also need to get an add-on that removes all the blank rows, because what the program does is it looks for the last row and then adds one. So you're going to need to remove blank rows, which means in the Google Play Store, I have a link here, and I can sort of point you towards it. But you need to remove blank rows. It creates a folder automatically called temperature on your computer or on the Raspberry Pi. So what you're going to want to do is you go into that folder called temperature, and inside that folder there's a program called temp.py, and that's the one that you want to make a change to. For those, has anyone encountered what's called fail? Okay. The reason it is encountering fail is because Google is recognizing this as a less secure app. What you want to do is check your Google Mail, your Gmail, and there'll be a setting on there saying, is this what you really want to do? And you'll have to go through this procedure to say yes, if that's what you want to do. If you set this up and just let it run and run and run, there's an infinite loop in here, and if everything works, it should just run until it doesn't run anymore, until you unplug it. One of the things that I found is after about 20 minutes, there's a hang-up sometimes. And after about 20 minutes, that infinite loop can't respond to that hang-up, and you're done collecting data. Which stinks if, this is what I actually use this for. I monitor my beer temperatures when I'm brewing beer, and I'm away for the weekend. What happens if my lager goes over 65 degrees? That's not good. So I need to, this program kind of stopped working for me, and I got some feedback on it from the Element 14 community, and they walked me through this. Basically what it means is we go into another part of the Raspberry Pi that's called cron. And what that allows us to do is to make an event repeatable in the Raspberry Pi, so that when it says every minute, wake up, run this program. When it's run, go to sleep. Repeat in a minute. And then it'll do that every minute. And you can make that happen upon boot up or anything along those lines. And so if you're going to do something with the camera or something else, putting things in cron tab is a really, really easy and good way to do it. And the Python program that I had you guys download is one that will repeat on its own until it fails. This will make it so that it doesn't repeat on its own. It executes once, and then it's done. Okay, so when you put it in cron tab, it makes it repeatable again and again and again. Okay, so at this point, what we're going to do with the Pi is more or less complete. We've set up cameras and taken pictures, saved those pictures, accessed those pictures in a couple of different ways. We have made local web servers, changed the website on there, and then sort of realized the way we can access these things from other computers. And we've built a temperature circuit, and for the most part, I think with maybe just a couple of exceptions, made the temperature circuit report to a Google account. So it's pretty impressive, all the things we've been able to accomplish just in one day. So it's really, really cool.